Hello guys, we are going to talk about DHCP operations. Dynamic Host Configuration Protocol or DHCP uses a server to automatically assign a range of IP addresses to network devices. In the past, devices were manually configured with specific or static IP addresses. This process was not only time-consuming but also resulted in user error, causing multiple devices to be configured with duplicate addresses. DHCP dynamically assigns IP addresses on demand, which minimize the chances of overlapping addresses, even though static IP addresses can still be assigned. Most organizations are going to rely on DHCP to simplify and standardize access to the network. Therefore, it is necessary for engineers to fully understand the functionality of DHCP in order to protect the enterprise against the various attacks that can target DHCP. DHCP not only dynamically assign IP addresses, subnet masks, and default gateways, it can also assign other parameters such as network time server and domain name server. DHCP uses UDP as the UDP port 67 from the client side, and the server uses UDP port 68 when DHCP client requests an IP address. So let's take a closer look at the sum of the messages that are exchanged between the client and the server during a DHCP negotiation. So we will start off with the DHCP discover message. When a device such as your laptop connects to network and it is configured as a DHCP client on its interface, it sends out a DHCP discover message. Number one message. This broadcast message on the local subnet uses UDP port 67, as I earlier said, in the search of a DHCP server in order to obtain an IP address. The next step is DHCP offer. When a DHCP server receives a discover message from the laptop, it selects an unused IP address from a pool and sends back a unicast DHCP offer message using UDP port 68. This offer to the laptop in our example contains an IP address, subnet mask, and lease duration. When the laptop receives the DHCP offer, it responds with the DHCP request broadcast message to accept. This is actually a confirmation request to verify that it can really use the IP address contained in the offer. The process this is not complete until the laptop receives an acknowledge from the server DHCP pack. This brings us to the last step of the process, when is the DHCP pack. The DHCP server responds to the DHCP request with a unicast DHCP pack, which acknowledges the address assignment and includes any other configuration parameter to be passed along to the laptop. Once received, the DHCP acquisition process is now complete. This is a simplification of a successful DHCP negotiation. Keep in mind that other messages that you might see include DHCP NAC, which is a negative acknowledgement from the server, the DHCP decline. Okay, keep in mind that there are other messages that you might see include the DHCP NAC, which is a negative acknowledgement from the server. The DHCP decline, which is sent from the client due to invalid parameter. The DHCP release sent by a client that is ready to relinquish his IP address, and DHCP inform when a client is requesting more information. So far, we have described the DHCP process, the same subnet. So, but if the DHCP server is not on the same subnet, then what will happen? What will be the DHCP client response and the server? So as you know, a router is not going to automatically forward a broadcast message without some type of intervention. This is where the DHCP relay agent function comes in. Its purpose is to forward the DHCP message between client and server on different subnet. When client DHCP message are received by a router's relay agent, it generates new DHCP message to send out another interface to remote DHCP server. This is also true for the DHCP replies from the server, which are then forwarded back to the client. Now that you understand how DHCP works, you may find it necessary to analyze DHCP packet. When you are monitoring or troubleshooting DHCP issues, this first example shows the output from the TCP Dump command on a Linux machine. In this example, we are listening to ETH0 here. This is the interface which is specified using the -I option. -E option is used. Okay. To display the source and destination MAC address. And the -N here, here, -E and -N option display addresses instead of names. You can use the command to view communication between the client and a server. From this output, you can observe the DHCP request and a reply message between the devices, and the last line showing the MAC address associated with an IP address. So in the second example, a DHCP is look little smaller. So anyway, the DHCP show the output from the DHCP Dump command on a Linux machine. This is another tool. TCP Dump and DHCP Dumps are different tools. Using the ETH0 interface specified with -I option. As you can see, we are getting more detailed information. For example, this is DHCP pack message, which is specified using option 3. Some of the other options displayed in the message are IP addresses, the subnet mask, the broadcast address, default route, DNS domain name, and DNS server address. So I will recommend you, if you want to analyze DHCP operations, you should use DHCP Dump instead of TCP Dump. So now that we have a better idea of how DHCP works, we need to understand some DHCP security vulnerabilities. These include DHCP spoofing and DHCP starvation. In this case, DHCP spoofing, the attacker insert a rogue DHCP server into a network. When a client sends out a DHCP discover packet, the rogue DHCP server responds with a DHCP offer packet before a valid server can. Their response time is very short or lesser than the original DHCP server. The rogue server then hand out an invalid IP address and designate itself as the default gateway for the unspecified client, unsuspecting client. So all traffic from client is then directed to the rogue server, which allow the attacker to sniff the packet before forwarding them to the real destination. This is sometimes referred to as a man-in-the-middle attack. With DHCP starvation, the attacker uses a rogue DHCP client to broadcast DHCP discovery request. Before that, we were looking in the DHCP spoofing. Now we are looking in DHCP starvation. The attacker uses a rogue DHCP client in this case and to broadcast DHCP discovery request with spoofed MAC address. But in DHCP spoofing, server issue a DHCP offer. Here, DHCP client is giving DHCP discovery request with spoofed MAC address. If enough of these rogue requests are sent out, the attacker can consume all the valid IP addresses from a production DHCP server. This is referred to as denial of server attack because all DHCP IPs has been allocated. This final example displays the output of a packet capture using Wireshark. This is actually an example of a DHCP starvation attack using a Linux tool called Yersinia. Yersinia, Yersinia, or whatever you call it. This tool can generate a large number of requests using spoofed MAC addresses, which can then consume all the IP addresses defined in the address pool configured on the DHCP server. This method of attack can also be used in conjunction with DHCP spoofing. If left undefended, DHCP vulnerabilities can allow an attacker to take control of traffic flowing through your network instead of the original network. So the next we are going to talk about subnetting.